Hello everyone, it's Tim. I just wanted to give a hopefully a helpful example to help out with the readings in the lab and all the discussion going on this week. I know as the class has gone on, it's gotten progressively harder. So hopefully this example helps clarify some things. So I just created a quick example that said that I surveyed 30 Oregonians and I find that 51% answered yes to the question, do you favor Portland getting an AHL team? So being from Michigan, I would love an AHL hockey team being out in the Northwest. So our null hypothesis for this would be there's no clear winning opinion on this issue. The proportion who would answer yes or no are each 50%. So 50% said yes, 50% said no. That's the null hypothesis. So the null hypothesis is saying there is no opinion either way on whether the state wants a hockey team. The alternative hypothesis, though, is that more than half of Oregonians think they should get an AHL hockey team, or more than 50% are in favor of getting a hockey team. And we'll use the normal 0.05 as the cutoff for a significant result. So first we need to create a standard deviation, and I used the formula from page 419 in your book, where it's the square root of the null value, or 0.05, times 1 minus the null value, or 0.5, and then you take this divided by the sample size of 30, and I got 0.09. Now I plug that into the standard z-score formula, where I have my score minus the null, 51, because that's what I found on my survey, minus the null, 50, divided by the standard deviation of 0.09, and I get a standard score or z-score of 11.11. So now what I need to do is I need to figure out what does that z-score actually mean. And a good way to find out what this actually means is to actually use your book. Now remember, in page 157 in your book, there's a z-score or a standard score table. So let's go there. Now I'm on the table. Again, I'm 157. I find my standard score of z. Alright, so I'm going down, and we have a standard score of 11.11. And we see that the table actually only goes to 6. But we see here that at this point we're already at 0.999, and we're at the 99.99 percentile. So this means that 6 is a very significant result. So we're saying what this 0.99 indicates is that the chance that this number happened by chance alone was 0.00001. So going back to this document, it was at we find that 11.11 was essentially at the 99.9 percentile, or 0.999. To obtain the p-value, we do 1 minus 0.999 and get 0.01. Now there's a lot more nines involved in there, but I just rounded it, and we get a 0.01. So our p-value, or the probability that this happened by chance alone, was less than 1%, which is very significant. So like I said, another way to say this is there is a 0.0001 chance that this number happened by chance alone. So this is very significant. So we find that my study found that, rightfully so, being biased, again liking hockey, that Oregonians want an AHL hockey team. And if anyone has any questions on that, please send me an email. I know I had to go through here pretty quickly. The last thing I want to touch on really quickly was type 1 and type 2 errors. So type 1 error essentially says you said that there's a significant result when there actually wasn't. So for my type 1 error that I could have made was saying that Oregonians want a team when in reality they do not. Type 2 error says that there is a significant result, but you state that there isn't one. So I could have made a type 2 error here by saying that Oregonians do not want a team when in fact they do. Again, hopefully this video helped out. I'm sorry I had to rush through it because of the parameters of only allowing 5-minute videos. But if anyone has any questions, please let me know. Thank you.